Hi, Assalamualaikum. Welcome back to my channel, Physics from 5 KSSM. Today we continue the next part in topic 3.2, resistance. In this video, I will discuss two learning standards, communicate about applications of resistivity of wire in daily life, and then solve problems involving formula of wire resistance R equals rho L divided by A. Okay, you can refer to your textbook, activity 3.3. In this activity, aim is to study and elaborate on applications of resistivity on conductors in daily life. When we talk about resistivity, resistivity is a constant that represents the type of material of a conductor used. Okay, the first one we want to discuss about the use of conductor as heating element. Heating element is the component of conductor that used, which can produce large amount of heat. The heat will become useful energy in the case of oven, iron, or cooking coil. Okay. The first one is state energy change in heating element. For this type of heating element, electrical energy convert to heat. Nichrome is always used because it's high resistivity. Okay, later we can look at the value of resistivity for nichrome wire. Okay, list electrical appliances which use heating element. Okay, for example, iron, electric oven, electric kettle, and hair dryer. Meaning all the electrical appliances that use heat as useful energy. State characteristic of material for heating element. High resistivity or high resistance, thus to produce large heat. More electrical energy convert to heat energy. High melting point, does not melt easily at high temperature. Okay. Okay, the next one, heating element, we want to discuss also about nichrome wire. Normally we use nichrome wire. Why? Nichrome wire is an alloy, mixture of nickel and chromium. It has high resistivity. The value is about 100 times 10 to the power negative 8 rho meter at 200 degrees Celsius. And high melting point, 40,000 degrees Celsius. So you can withstand high temperature. That cause no corrosive at higher temperature. So this one is good. For example, used in kettle. If the conductor corrode, means the water is not safe to drink. Okay, so no corrosive at higher temperature is better. Experience small expansion when heating, does not expand. These properties make heating element more efficient. Okay, there are many appliances in our house using this heating element. Okay, the second one is electrical wiring at home. The first one is connecting wire. In the lab, we always use this connecting wire. For connecting wire, normally we choose copper because it has low resistivity, which prevents the wire from heating up too quickly when current flows through it, meaning less heat is produced, less energy loss as heat. Connecting wire, the useful energy is not heat energy. Heat energy is wasted energy. So we don't want heat to produce too high, so that one will be wasted. So we choose copper. Now we discuss more about electrical wiring at home. Fuse, the use of fuse. This is fuse. We can always see it in the 3-pin plug. Okay, fuse can be found on main switchboard and plug. What is a function of fuse? Okay, to control exit current flow so that no damage to electrical appliance and no burning happens. Meaning if current is overload, the fuse will melt. Okay. Thus, the characteristic of material for fuse is a very thin with low resistivity and has specific melting point that will melt when exceeded current flow through it. So once the fuse melts, it will block the current flowing to the electrical appliance. Activity 3.4, this one is to seek information about resistivity of conductors, non-conductors, semiconductors, and superconductors. For the first one, we discuss about conductors and superconductors. Okay. Conductors is material that can conduct electricity, means allow current to pass through it. Resistivity, low resistivity. Okay, if we compare among the conductors, you can see the value of resistivity is smaller, so low resistivity. Example, iron and carbon. Superconductor, a material that conducts electricity without any resistance at certain temperature. If without resistance means no energy loss. Resistivity has zero resistance at critical temperature. Example, caesium at 1.5 Kelvin or lower. How about non-conductors and semiconductors? Non-conductors means material does not conduct electricity or good insulator. It has highest resistivity, so it blocks current to pass through. Example, plastic and wood. Semiconductor, material that conduct electricity better than insulator, but not as good as conductor. Mean it can function as insulator at low temperature, so it can become conductor at high temperature. So resistivity also is between insulator and conductor. Example, silicon, germanium. Okay, next is about superconductors. We want to discuss more on superconductors. Superconductors are material that conduct electricity without any resistance. Therefore, no energy is lost when current flows through superconductor. Critical temperature Tc is the temperature when resistivity of superconductor becomes zero. If you look at the two material here, non-superconductor, so you can see the resistance never becomes zero. There's always resistance. For superconductor, you can see resistance also increases with temperature, but at certain temperature that we call critical temperature, suddenly resistance drops to zero. So what happens then? The current now flowing at maximum without loss of energy. So it becomes a perfect conductor, or we call it superconductor. In 1911, a Dutch physicist, Kamerlingh Onnes, investigated the resistance of mercury. He discovered that when mercury was cooled to temperature of 4.15 Kelvin, its resistance suddenly dropped to zero. Very low temperature. It's about 269 degrees Celsius, negative 269 degrees Celsius. The mercury at this temperature becomes superconductor. Okay, this is the person. Okay, superconductor is material that has zero resistance at critical temperature. For example, metal, ceramic, inorganic material that can conduct electricity efficiently at specific temperature. These materials have no electrical energy loss in the form of heat, sound, and others. You can say zero energy loss. The graph shows that when temperature of superconductor decreases, then resistance also decreases until achieve specific temperature known as critical temperature. Critical temperature achieved when resistance suddenly reduced to zero. But normally for superconductors, it needs a very low temperature to become superconductor, or for the resistance to drop to zero. Okay, let's look at more about superconductor. When a superconductor is placed close to magnetic field, superconductivity effect occurs. The induction current flows continuously and causes the superconductor to float on the magnetic sheets. The magnet here will produce magnetic flux. So the superconductor, which is at certain temperature, resistance drop to zero, when you place it here, it will produce a Meissner effect. Okay, it will cause the superconductor to trap in the magnetic flux of magnet. It will trap at certain distance from the magnet and floats there. Okay. Advantage of superconductor in daily life, it can maintain high current. Loss of power is too small during transmission of electricity through transmission cable. No energy loss. Small motor or generator can be used. Because when resistance drop to zero, the factors like length of wire, thickness of wire does not give effect to the resistance. So instead of using very long wire for the generator, we can just use a small wire or a short wire. That's why we can use a small motor of generator that can function same as the regular generator. That's the advantage of superconductor in daily life. Okay, so that one is about a superconductor. So until now, still cannot find a superconductor that can function at high temperature. So we need to cool down to a very low temperature to function as superconductor. Okay, you watch this video. This one will explain how superconductor. So this one will produce the application of a maglev train, the magnetic levitation train. We can see the train will float about 1 cm from the rail. Thus, when the train travel, it does not touch the base part of the rail. Okay, so it can travel at very high speed without friction, okay, between the bottom part of the train and the rail. Okay, let's look at some question involving wire resistance. Number 1, calculate total resistance for a roll of copper wire length 10 meter and cross-sectional area 2 millimeter squared given resistivity of copper is 1.72 times 10 to the power negative 8 rho meter. Okay. So we can just list out all the information and then use the formula R equals to rho L divided by A. But make sure you check the unit. Meter all must be in meter. If not, you need to convert to the same unit first. So you calculate for resistance using this formula. So you will get R equals 0.086 ohm. Second question, for his wiring home, Ahmad bought a roll of aluminium wire, radius 0.5 millimeter, length about 500 meter. Given the value of the resistivity of aluminium at 20 degrees Celsius is 2.8 times 10 to the power negative 8 rho meter. What is resistance of aluminium wire? So you just list out all information. For L, 500 meter, resistivity, and then the radius of the wire, R equals to 0.5 millimeter, you convert to meter, and then to find the cross-sectional area, use formula pi r squared, you will get the answer. And then R equals to rho L divided by A, so just substitute all the values, so you will get R equals 0.176 ohm. So just use the formula R equals to rho L divided by A. You can list out all information first and then try to solve the problems. Okay, so that's all my video today. So I hope you understand all the concept of electricity for this topic 3.2 resistance. You can go and search more information on the topic of superconductor. It is a very interesting topic. So that's all for now. Thank you for watching. Bye.